can you take us through the plan from the first test flights, starting first half of 2025, and then perhaps to the most important steps in order to reach commercial certification in 2028? But if you could say some of the steps you need to go through.
Yeah, I mean, I can start by elevating a little bit. So my the thing that we really want to change with Heart, that I think that we identified early on, was that we were thinking not just about like how does an aircraft look in the 21st century, but how does an aerospace company operate in the 21st century. And if you want to look at a little bit what's the state of the art today of aircraft development, it's been described with this sort of V model diagram, and it's just going to be a little bit technical, but essentially you go through these gates of development where you say, I'm going to do a conceptual design, I'm then going to do a preliminary design, I'm going to do detailed design, I'm going to do that with the few suppliers. They're going to go in, build their components, then you're going to get them, you're going to assemble them, and then you're going to go flight test, and then you're going to certify. Essentially, well, all of these things happening a little bit overlapping, but essentially what that means is that you get one iteration of development. And the problem with that is that works if you're only doing an incremental change to your last development. So if you're building a new version of an established airframe, and you're doing sort of mild improvements on that, then that one iteration is going to be great. Heart is trying not to build an aircraft with too much new stuff, too much innovation, but as you're building a hybrid system for the first time in this, going through that process of defining the architecture, defining the detailed design, building it all out, then designing the components, and then working all the way up into a certified aircraft and getting that completely right on the first time, it becomes very, very time consuming. And it takes a very long time until you actually have hardware. And that means that you're creating a suboptimal product essentially the product is not going to be as good as it could be. And there's really no reason why to do it that way. I think the reason that people have done it that way is that they feel that it's been too prohibitively expensive to test early. But actually testing early, probably the thing that could save you a lot of money. So if you look at it maybe from an analogy, I would say that think about software development. If a software development worked like you were creating this complex piece of software, you had a bunch of different companies working on a software program, and everything was defined, in a Word document, that everybody wrote the requirements for the software in the Word document. And then you started, collaborating, writing interface control documents, then starting writing the code, but not ever compiling the code. And then sort of, instead you'd create cross-functional groups that would be looking through the code and making sure that it would run. And then you've done it all and you worked for several years, and then you press the compile button and the software works. I mean, that's a little bit how aerospace company works. There's nobody in the software industry that works that way, right? There's nobody that what you do with the software is you sort of set up your environment, you do your minimum viable product, you actually do like a hello world, making sure that it sort of is working, and then you're compiling, and you're continuously compiling, debugging, changing, and obviously that's very easy to do for a software product because the cost of pressing that compile button is zero. When you're in aerospace, obviously the cost of testing is not zero. It can be quite substantial, but it's not. But in the grand scheme of things, with the technology development that we've seen, for instance, both in digital testing, which we were using extensively, but also in the field of rapid prototyping, everything from 3D printing components ubiquitous CNCing, so sort of creating components to electronics and everything that is the modularity, the modularization, the software basis of electronics, the ease in which to build composite parts as one-offs. I mean, if you start actually building your process reflecting that new reality that we are in, you can get the price of pressing that compile button is not that high. So that's what we're trying to do with this, and we've actually been demonstrating since we've started this company with our first propulsion system demonstrated in 2020. The ITF, the Iron Burr that we built for all the system in 2022, and now in 2024, going in and actually rolling out our full-scale demonstrator aircraft, starting with the charging and the taxi in 24, and then getting into flight in 25.